So are you ready to look at 8 in another way, in a way that your 3 to 7-year-olds will have every single step put in place to make this really easy to use for children aged 7 to 11 and older? So here's my 8. This time I'm going to remove it from the 10 frame. It's still got that handy pattern. It's not as easy to see its relationship with 10 now. It actually can look fairly similar to 10 when it's not on the 10 frame. If we look at what 10 would look like, it makes a similar pattern to 8. You can see this. It's really important that we get hands-on with this. And the work that we do right from nursery, this idea about dropping things down on a tray and they all end up all over the place. And the first thing we do is we look to see what can we see. And we know that that amount and that amount and that amount and that amount, for example, are all the same amount. And we learn in time that in English, it's called 1. So I've got 1 there, 1 there, 1 there, 1 there. Maybe they choose to look at 1 there. Of course, depending on what they know, they could maybe look at 2. And we've got a 3 here. We drop them down again. They might fall in this pattern this time. And we've seen children as young as 3 doing this. We've got a 2 and a 1 and a 1 and a 2 and a 1 and a 1. And we always do 1s, 2s, and 3s to begin with. So what that leads us to be able to do is if I moved to prove how many groups of 2, or just can I get groups of 2 out of this number? Look, this whole number can go into groups of 2. It isn't really important how many groups of 2, even though I said that, but the idea it can. If I'd had this many, we can make groups of 2, but there's 1 here that needs another one to be a group of 2, or we'd need to remove it. So this is the idea that that quantity does not have 2 as a factor. It can't be divided into equal groups of 2 without a remainder. And that amount does. This amount here doesn't have 2 as a factor, but if we added 1 more, if this is unknown number, plus 1 makes it a number that does have a factor of 2. Is that total a multiple of 2? Well, no, because we've got 2s and we've only got a 1 there. Whereas if we add 1, or if we were to subtract 1, the total is now a multiple of 2 and so forth. So that's how that very simple perceptual subitizing allows children later to understand that things like factors and multiples. Let's go back to our 8. Quite hard when you're younger to see the groups of 2 in 8, and we want them to see them. So the best way to do it is move it to prove it. So let's move them out of the way. There's a 2, there's a 2, there's a 2, and there's a 2. And we've got a group of 2 here, 2 groups of 2, and of course 2 groups of 2 equal to 4, so it's quite a difficult thing to look at how many are in the groups versus how many groups. But when you have got it back together again, we've got those 4 2s in 8. Now, anything that can be divided equally into 4 equal groups, each group could be described as a quarter. So the whole, which is 8 in this case, has been split into 4 equal groups. So if 4 children were sharing 8 biscuits, each child's getting 2. So we're already then into fractions, and that's when it starts to get really, really exciting in a really simple way. Because if this is a quarter, and this is a quarter, and this is a quarter, and this is a quarter, how many are equal to 3/4? So what's 3/4 of 8 equal to? Well, there's 4/4, so 3/4 is this bit. And we've got 6 altogether. Of course, 3/4 can be any of the quarters. It could be that one, and that one. It doesn't matter. And it doesn't have to be laid out like this. But look, we've already got into some more complex maths. What about if I only look for 2/4? You can see that 2 of the quarters is equal to 4. There's another 2/4 equal to 4. It doesn't matter which 2/4. But you can also see here that those 2/4 that are equal to 4 and those 2/4 that are equal to 4, they're also showing us that 2/4 is also equal to 1/2. So this stuff is exactly what your children are doing further up the school. So half, which is equal to 2/4, So half of, or 2/4 of 8 is equal to 4. And that again goes on to be some much more complex mathematics later. But it's all coming from the fact that children can see parts in the whole. If you're teaching your children to count to find out how many, 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. I only said 2 once. 1, 2, 3, 4, 5, 6, 7, 8. It's not obvious there's 4 2s in there. It is if you look, but the way that we're teaching, it isn't obvious. And the idea as well, 2, 4, 6, 8, we often teach like that, whereas actually what it is it's 2 and then another 2, 4, and looking at the whole amount subitizing, another 2, 6, another 2, 8. You're talking about the cumulative total each time. So I hope this is exciting. Show it to the person with the purse strings, get them excited, get them realizing that your Key Stage 2 children do not have these skills. And actually, just like with all of you at the age you are as adults, we can give children these skills so easily, and you will change the way they calculate for life. And most importantly, the way they engage and love maths for life.